Imagine that at midnight, every person responsible for running your city simply disappeared. No engineers, no delivery drivers, no control room operators, no repair crews. At first, almost nothing would seem different. The lights would still glow. Water would still leave the tap. Your phone would still connect. But beneath the streets, a countdown would already have begun. Because a city is not a place. It is a machine that must never stop. From above, a city looks like a collection of buildings. But look closer and it begins to resemble a living organism. Roads carry food and people like arteries. Power lines transmit energy like nerves. Water pipes move an essential fluid beneath the skin. Communication networks form a kind of shared brain. Millions of separate parts must cooperate every second just to create what we experience as an ordinary day. Begin with electricity. The energy lighting your room may have started hundreds of kilometers away, inside a dam, a wind turbine, a solar farm, or a power station. But generating electricity is only the beginning. It must travel through a vast network of transmission lines, transformers, substations, and cables. And unlike water or food, large amounts of electricity cannot simply sit on a shelf waiting to be used. At every moment, the electricity entering the grid must closely match the electricity being consumed. When millions of people wake up, start factories, charge vehicles, or switch on air conditioners, operators and automated systems must respond. Too little power can destabilize the network. Too much can also create problems. The entire grid is a continuous balancing act, performed so smoothly that most of us never realize it is happening. Before electricity reaches your home, its voltage is reduced in stages. Giant substations transform it for regional distribution. Smaller transformers prepare it for neighborhoods and buildings. Breakers and protective systems constantly watch for faults. When you press a light switch, you are completing the final step of a journey involving machines, computers, cables, and human decisions spread across an enormous distance. The result feels instant because the system is always ready. Now turn on a tap. The water may have begun as rain falling months or even years ago. It collected in a river, lake, reservoir, or underground aquifer. From there, pumps and gravity carried it toward a treatment plant. Before this water could safely enter your home, it had to pass through one of the most important and least visible industrial processes in modern civilization. Treatment begins by removing debris and suspended particles. Chemicals may help tiny impurities join together so they can settle out. Filters capture material too small to see easily. Disinfection reduces dangerous microorganisms. Sensors and laboratory workers check the water throughout the process. Only after meeting strict safety requirements does it enter the distribution network. A hidden maze of pipes running beneath roads, buildings, and sidewalks. Water must arrive with enough pressure to climb buildings and flow from taps, even during periods of high demand. Pumps provide much of that force, elevated tanks and reservoirs. Use gravity while also storing water for peak periods and emergencies. Pressure zones help serve neighborhoods at different heights. Every glass of water depends on carefully managed pressure. Too little, and upper floors go dry. Too much and aging pipes can break. The system does not end when water disappears down the drain. Wastewater flows through another underground network toward treatment facilities. Screens remove large objects. Tanks separate solids. In many plants, microorganisms consume dissolved waste while oxygen is pumped into the water. The treated water can then be safely released or reused. Without this system, disease and pollution would spread rapidly. Modern sanitation is one of humanity's greatest invisible achievements. Then there is everything the city throws away. Every day, homes, restaurants, offices, hospitals, and factories produce a mountain of waste. Collection vehicles move through carefully planned routes, often while most residents are asleep. Recyclable material may be sorted by machines and workers. Organic waste may become compost or energy. The rest must be contained and monitored. Waste appears to vanish only because an enormous system carries it somewhere else. A city also needs to eat. Most urban residents produce almost none of their own food. Yet stores remain filled with products from farms, factories, and oceans around the world. Behind every shelf is a chain of growers, processors, warehouses, ships, trains, trucks, and software. Deliveries must arrive in the correct order, at the correct temperature, before the food spoils, and before millions of customers decide what to buy. Perishable food depends on the cold chain, an uninterrupted series of refrigerated spaces. A fish may remain cold from the moment it leaves the water until it reaches a restaurant. Vaccines, medicines, dairy products, meat, and fresh produce rely on similar control. A delay, failed refrigerator, or incorrect temperature can ruin an entire shipment. The abundance inside a supermarket is therefore not permanent. It is a carefully maintained flow. People must move as well. Roads, railways, buses, sidewalks, bicycle routes, bridges, and tunnels form overlapping transport networks. Each has limited capacity. When too many travelers choose the same route at the same time, congestion appears. Traffic engineers study these flows, much like water engineers study pipes. They adjust signals, redesign intersections, schedule trains, and respond to accidents, all to keep the human current moving. Much of transportation is really a problem of timing. Signals can be coordinated, so vehicles meet a sequence of green lights. Trains must maintain safe distances, while arriving frequently enough to carry crowds. Buses need to connect with other routes. Deliveries avoid the busiest hours. A difference of just a few seconds, repeated across thousands of intersections and journeys, can determine whether a city flows smoothly or becomes trapped in its own movement. Another kind of traffic moves beneath the streets. Data. Messages, videos, bank transfers, navigation requests, and business records travel mainly through physical cables. Fiber optic lines carry information as pulses of light. Data centers store and process enormous volumes of it. Undersea cables connect continents. What we call the cloud is not floating above us. It is a worldwide collection of buildings, machines, cables, cooling systems, and electrical connections. When you use a mobile phone, it communicates by radio with a nearby antenna. The network then decides how to route your call or data, often through cables for most of the journey. As you move, the connection is handed from one cell to another. Thousands of devices may compete for access in a small area. The experience feels wireless, but behind that final radio link stands an intensely physical infrastructure. Money has its own infrastructure. When you tap a card, the payment does not simply jump from your account to a shop. A message travels through payment networks and financial institutions. Systems check the account, look for signs of fraud, approve or reject the transaction, and record what happened. Settlement between institutions may occur later. In seconds, multiple organizations coordinate to create the simple message. Payment approved. Some services cannot tolerate even a brief interruption. Hospitals need reliable power, clean water, medical gases, communications, sterile supplies, and trained staff. Emergency dispatchers must identify where help is needed and which team can respond fastest. Backup generators wait for power failures. Fire stations track equipment and water access. These systems are designed with layers of protection because, during an emergency, ordinary infrastructure becomes a matter of life and death. Even a highly electric city still depends on fuel. Ships, aircraft, construction equipment, emergency vehicles, backup generators, and many delivery fleets require a steady energy supply. Fuel moves through ports, refineries, pipelines, storage terminals, and trucks before reaching the machines that use it. If one link fails, the effects travel outward. Delivery slow. Repairs are delayed. Backup systems lose their backup. Energy connects nearly every other urban network. Every part of the city is slowly wearing out. Metal corrodes. Concrete cracks. Filters clog. Batteries weaken. Roads deform under traffic and weather. Maintenance teams search for small failures before they become large ones. Increasingly, sensors reveal changes in temperature, pressure, vibration, or electrical current. But technology does not eliminate maintenance. It helps people decide what to inspect first in a machine far too large to examine all at once. The city never truly operates by itself. While most residents sleep, operators monitor power. Engineers inspect water systems. Bakers prepare the morning's bread. Mechanics repair trains. Cleaners restore public spaces. Drivers bring food into markets. Security teams watch critical facilities. Their work is often invisible precisely because it succeeds. We notice infrastructure when it fails, but rarely notice the people who prevent that failure every ordinary night. Cities must also prepare for events they cannot control. A storm increases electricity faults, blocks roads, floods tunnels, and overwhelms drainage systems at the same time. Forecasts give operators time to position repair crews, lower reservoir levels, protect equipment, and warn the public. Planning does not prevent the storm. It changes what happens next. Resilience is the ability to absorb a shock without allowing every connected system to collapse. Because urban systems are connected, failure can spread like falling dominoes. A power outage may stop water pumps and traffic signals. Congestion can delay repair crews and fuel deliveries. Communication towers may continue on batteries, but only temporarily. Shops may function, but no functioning payment systems. Each service depends on others, and those dependencies are not always obvious until something breaks. This is called a cascading failure. A blackout may begin with a damaged line, failed machine, extreme weather event, or unexpected imbalance. Protective devices disconnect the affected equipment to prevent greater damage. But the electricity that once used that route must go somewhere else. Neighboring lines can become overloaded and disconnect as well. Operators must isolate the problem, stabilize the remaining network, and understand what happened before they can safely restore power. Recovery happens in stages. Critical services such as hospitals, communications, and water infrastructure receive priority. Power stations and transmission paths must be restarted in a controlled sequence. Adding too much demand too quickly can destabilize the grid again. Similar priorities guide recovery from floods, earthquakes, and cyber attacks. Restoring a city is not like flipping one giant switch. It is more like rebuilding a living network, connection by connection. The secret holding all of this together is coordination. Power companies speak with emergency services. Water operators monitor electricity risks. Transport agencies share information about closed roads. Hospitals track available capacity. Businesses adjust deliveries. No single person controls the entire city, yet thousands of decisions combine into organized behavior. The city's true operating system is not one computer. It is communication between people, institutions, rules, and machines. There is always a tension between efficiency and resilience. One large pipeline may be cheaper than several smaller ones. A warehouse with minimal inventory costs less to operate. A tightly scheduled network wastes little capacity, but efficiency can create fragility. Resilient systems include spare capacity, alternative routes, backup power, stored supplies, and trained people. These protections may look unnecessary. Right up to the moment they become essential. You are not merely a passenger inside this machine. Your choices affect its behavior. Electricity use changes demand on the grid. Travel choices shape congestion. What you throw away influences waste systems. During emergencies, accurate information and responsible behavior can reduce pressure on essential services. Even allowing an ambulance to pass is a tiny act of system coordination. A city works because millions of people participate, usually without thinking about it. The next time you drink a glass of water, cross an intersection, buy fresh food, or send a message across the world, pause for a moment. Behind that simple action is a chain of systems stretching far beyond what you can see. Pipes, cables, roads, machines, software, and people are working together to make the ordinary possible. Civilization is not only what we build, it is what we continuously maintain. A city may look permanent, but every ordinary morning is an achievement repeated from scratch. Energy must flow, water must move, food must arrive, waste must leave, information must connect, and people must keep every part working. This hidden machine is complex, imperfect, and surprisingly fragile. But it is also one of humanity's greatest creations. And once you learn to see it, The world around you will never look ordinary again. This is how the world works.